Derive, derivation of units. Mm, mm, mm. Oh, okay. Now, to derive unit, what are you going to do? Well, you need to list all the units that you know. How many of those can we list? Let's just start with the one that we can list. We have velocity, right? We have acceleration. We have momentum. We have force. We have impulse. We have power. Yeah. Power. We have prayer. We have work done. And then we have, okay. We have, which one again? Gravitational force. We have, all right, density. Let's put that one up there. All right, if you remember any of those, we'll add to the list. Let's just continue for now. Let's start up. All right, so if it is density, what's the unit of density? If you can have a question, which of these is the unit of density? And then you have option number A. And you have option number B. And then option number C. Now, which of these is a unit of density? The unit of density in the options are, you don't know them if you don't know how to derive the unit. All right, what's the formula for density? Density is mass over volume. Density is mass over volume. What's the unit of mass? The unit of mass is kilogram. What's the unit of volume? The unit of volume is meter cube. If you divide this is going to give me kilogram, meter, per meter, per meter, per meter. All right, meter raised to the power of -3. So this is the right answer over there. So let's go to the next one. What's the unit of velocity? Well, you can have this. Velocity is equals to change in distance over change in time. And this is displacement over time taken. So V is equals to, the displacement over there is meters. Meters. Then the time is in seconds. Seconds, yeah. And then when you divide meter by second, it will give you meter per second. So this is the unit for velocity. So go to another one, acceleration. Acceleration is a junior sister, is a junior brother to velocity. Oh, they look alike because from velocity you can get acceleration. You should know that. Now, acceleration means change in velocity over change in time. So what's the change in velocity? Meter per seconds minus 1 over time, which is seconds. Minus 1, the law of indices. The law of division in indices, you subtract the index of the numerator with one of the denominator. All right, we do that. Minus 1, minus 2. So this is the unit for acceleration. All right. We have another one. Momentum. Momentum is mass times velocity. Now, what's the unit for mass? Mass is in kilogram, and then velocity, we've done that, meter per seconds minus 1. When you add these together, you're going to have kilogram, meter per seconds minus 1. So this is the unit for velocity. Let's give you a question. A question says, which of these is a unit for force? Which of these is a unit for force? Let's say we have kilogram, meter per seconds, kilogram, meter per seconds. Which one is the unit for force? Now let's solve for force. Well, force is mass times acceleration. and mass is kilogram, and acceleration is meter per seconds per seconds. Multiply this, you're going to get kilogram meter per seconds per seconds, or the unit for force is Newton. The unit for force is Newton. All right, now let's go ahead. What's the unit for impulse or impulse? Impulse is force times change in time. Impulse is force times change in time. All right. So let's say force, you can use kilogram meter per seconds minus 2 times by seconds. Minus 1 in the law of indices, the law of multiplication, where you're multiplying two base of two same bases. What you're going to do is to add the index. So minus 1 plus 1 is minus 1. So we have kilogram meter per seconds minus 1. But meanwhile, if you use force to be Newton, Newton times seconds, of course, this is Newton seconds. So that's the final answer. Newton seconds or kilogram times meter per seconds minus 1. Raised to the power of minus 1. All right. We have power. So what's the unit for power? All right. Power is equals to power. What's power? Power is work done over time taken. Anyway, but we're going to find work done. So we have work done here. With this, we can find this and this at the same time. So what's work done? Power is work done over time taken. So let's go solve for work done. Where work done is force times distance. We want to use kilogram for it. Kilogram meter per seconds times by distance, which is in meters. All right. Do you know where I got this kilogram meter per seconds? Because force is mass times acceleration, and mass is kilogram. Acceleration is meter per seconds. Okay. Gotcha. Okay. All right. So what we have here, 1 plus 1, that is kilogram meter raised to the power of 2, second raised to the power of 2. So this is the unit for work done. Right. Let's create a space here. So that power is equals to the unit for work done, which is work done over time, is equals to kg meter per seconds to the power of 2 times meter times seconds per seconds. All right, we're dividing by seconds. If this minus 2 minus 1 is minus 3, so I'm going to have kg meter is to the power of 2, then seconds minus 2 minus 1 is minus 3. So this is the unit for power. All right, so that's that. But if your question or if your answer is in Newton seconds, Newton, if the force that you are using, I want to explain something. Let's decide to change force into Newton and see what we're going to get. So right now, we want to change force into Newton. Force is Newton now, so we're multiplying it by distance, which is meter. So the work done is Newton meters. Okay, Newton meters. All right, so we have the power is work done over time. So Newton meter divided by seconds. So what you're going to have will be Newton meter seconds minus 1. I hope so. That's what we'll have. Now, power is work done over time. Take it, yeah. And then if work done is force times distance, take it, yeah. Force is Newton. Distance is meter, so force is also Newton meter. Take it? All right. So power is work done over time. Newton meter over seconds. Newton meter raised to the power of minus 1. Good to go. So power, that's power. All right. Let's go back for prayer. So what is prayer? Prayer is force over area. Let's decide to use the Newton for force for sleep. So we have Newton over meter raised to the power of 2, because area is length times breadth, which is meter raised to the power of 2. So we have these to be Newton meter per meter. Newton per meter. That is Newton meter raised to the power of 2. But what if force is kilogram meter per seconds? All right, so this will become prayer will become force over area, and force is kilogram meter per seconds over meters in square, then 1 minus 2 is minus 1. So what we're going to have is kilogram, meter minus 1, seconds minus 2. And that is for prayer. And prayer is force over area. All right, so we'll talk about work done. If you're with us, you will notice we have solved for work done. But if you want to solve it, you can pause the video and solve, or you solve and drop the answer on the comment section. So we have gravitational force. I want you to pay attention to this one. Gravitational force. Now, force of gravity, Fg, is equals to the capital G, M1, M2 over R squared. So now we want to get out this gravitational force. This guy there, we want to make it the subject of the formula. So we're going to put a 1 here and cross multiply. So I have G M1 M2 is equals to Fg R squared. All right. So this is two of those. What I'm going to do is to divide by 2m. M raised to the power of 2. 1 plus 1 is 2, which is m squared. So I can say this is equal to, this will give me gm squared is equals to fgr squared. So if I divide by m squared, divide by m squared will cancel m squared. So what I have here is that g is equals to fgr squared over m squared. So that g is, do you understand what I'm doing? All right, let me take that again. We're trying to make gravitational force the subject of the formula. And then we'll put a 1 here, we'll cross multiply. This one will come to this side, this one will go to this side. This one will go to this side, this one will come to this side. Then we do that, then we have gravitation, we'll have this over there, this over here, multiplying this one over there. And then we have this guy, m times 1 is m squared. And then this m squared, then we cancel out m squared. What we do on this side, we do on this side. What do we do on the other side? We do on the other side. So that we can make the equation appropriate. So we have this there.